Hey team, I'm Maddie, welcome to Science Side Up, and today we're talking all about humidity. Humidity is probably something that you are familiar with, but you're probably not used to measuring it in 12 million different ways. Why do we measure it in 12 million different ways? I do not have a good answer for you. But there's three main terms that I want to introduce you guys to today. That's relative humidity, specific humidity, and mixing ratio. Relative humidity is probably the one y'all are most familiar with. So when I was writing the script for this video, it was 91 degrees outside and 43% humidity. So when we see humidity measured in a percent, that like 43%, like it usually is in weather forecasts or on your favorite weather app, that is relative humidity. Relative humidity measures how much water vapor is currently in the air versus how much water vapor can the air possibly hold, and it has units of percent. So 100% humidity would be the air has as much water vapor as it can possibly hold. It can't hold any more, and if you tried to shove more water vapor into that parcel of air, it would immediately condense out into a liquid. So for example, if you were inside a cloud or in fog, the relative humidity in those two places is going to be 100%. Specific humidity is different from relative humidity in that specific humidity is a measure of exactly how much water vapor there is in the air right now. So specific humidity actually looks like this. Specific humidity is the mass of the water vapor divided by the mass of the water vapor plus the mass of the dry air, and this is going to have units of grams per kilogram. So how much water vapor do I have in 1 kilogram of air? Mixing ratio, super similar, looks like this. It's the mass of the water vapor over just the mass of the dry air. It's also measured in grams per kilogram. Why do we have these two different things when they're so similar? I'm pretty sure mixing ratio is a term that sort of comes over to us from chemistry. I'm not exactly sure where specific humidity came from, but these guys are almost interchangeable, but that is the difference. The difference is in the denominator. For mixing ratio, it's just the dry air. For specific humidity, the mass of the water vapor is included in the denominator. Realistically, you can use either of those guys to calculate relative humidity. Relative humidity then would just be this. The, let's say, specific humidity divided by the saturation value and then times 100% to get us into the right units. So what is this saturation value, and why is relative humidity often more intuitive than specific humidity or mixing ratio? Hey team, editing Maddie here. So we will get to the answers of that question actually in the next video. As I was editing this guy was getting longer than I wanted it to, so I decided to cut it in half. So anyway, I will see you guys over there in the next video. Okay, bye.